Okay, everyone, we are taking a look at problem number 3 from the equilibrium constant worksheet, where carbon monoxide is reacting with nitrogen dioxide in order to form carbon dioxide and nitrogen monoxide in equilibrium. We're going to be setting up an ice table where we have 0.25 moles of each gas placed in 1 liter flask, which means the initial concentrations of all 4 gases is 0.25 moles per liter. Now, the equilibrium constant is 1.46 times 10 to the 2, or 146, which means that this will favor the products, meaning that we have an unknown quantity reacting in the products, becoming products, as well as an unknown quantity leaving the reactants or reacting, meaning that we've got 0.25 minus X as the concentration of both reactants. We have 0.25 plus X as our concentration for both products. Just going to erase a little bit of this here. Okay, we're going to enter this into our equilibrium expression. Now, the equilibrium expression, remember, is just products over reactants. Now, the products have the same concentration and the reactants both have the same concentration. 0.25 plus X for the products, 0.25 minus X for the reactants. And so as we enter these values into our equilibrium expression, 146 for K, for the products, we're going to just put 0.25 plus X. We're going to square it because it's being same thing being multiplied by itself. 0.25 minus X squared for your reactants. When you square root both sides, you have 12.08 is equal to 0.25 plus X over 0.25 minus X. Again, we are just square rooting both sides of the equation. Multiplying both sides by the denominator leaves you with the value of 0.32 minus 12.08x is equal to 0.25 plus x. We'll then move all the x's over to one side, move the numbers over to the other side. That will be collecting like terms. 2.77 is equal to 13.08x, which means 0.21 is equal to your x. So our reactants, the reactants, 0.25 minus x. Well, if we take 0.25 minus x and we've now solved for x, means that these will be now 0.04 moles per liter, and that will be both of them. 0.04. And the products, 0.25 plus x, well, that's going to now become 0.46. 0.46. All these concentration units are in moles per liter. So we're going to just throw in the units there. We can write this out as a nice formal statement with the reactants concentration as being 0.04 moles per liter, and the products, running out of room here, concentration is equal to 0.46 moles per liter.